Hi, the previous video covered the terminologies related to the graph of a quadratic function. This video will cover some of the properties of the graph of a quadratic function when the quadratic function is in the standard form. So let us see what is the standard form of a quadratic function. The standard form of a quadratic function is y is equal to ax square plus bx plus c. This is the standard form of a quadratic function. And in this video, we will see if the quadratic function is in this form, then what will be the vertex of the quadratic function, what will be the x-intercept of the quadratic function, the y-intercept of this quadratic function, and also the axis of symmetry. These are the four things which we will see for a particular quadratic function which is in the standard form. Okay, so let's move ahead. Now, we know that the x-intercept of a quadratic function are nothing but the zeros of the function. Zeros means the point where values of x for which the function fx or y becomes 0. These are called the zeros of the function, or they will be the x-intercept of the graph. Okay, so our first thing is to find the x-intercept of the graph. So now our equation is y is equal to ax square plus bx plus c. We want to solve it for x where y becomes 0. So ax square plus bx plus c is equal to 0. Okay, now we have to find the values of x. We will be applying the quadratic formula which says that x is equal to minus b plus minus square root of b square minus 4ac over 2a. Let's try sketching the graph of a curve, quadratic curve. Okay, so we see that this point here and this point here are the 2 points for which our y is becoming 0. This is y-axis and this is x-axis. So we have figured out the values of these 2 points as minus b minus root of discriminant over 2a, and this is minus b plus root of discriminant over 2a. We have got the 2 x-intercepts. Now, what is axis of symmetry? Axis of symmetry is a line along which the parabola is symmetrical. If we try to fold the parabola along this line, it is symmetrical. So this means that this axis of symmetry passes through the midpoint. This distance is equal to this distance. Then only it will be symmetrical, correct? So we try to find the x coordinate of this midpoint. And we know that the x coordinate of the midpoint is given by x1 plus x2 over 2. Okay, the x coordinate of the midpoint is given by x1 plus x2 over 2. In our case, x1 is this point here. So minus b minus root of delta over 2a plus x2 is minus b plus root of delta over 2a, and the average of this. So x comes as minus b over 2a minus root of delta over 2a minus b over 2a and plus root of delta over 2a whole upon 2. This cancels off, so we are left with x as minus 2b over 2a whole upon 2. This 2 and 2 goes off, so we are left with minus b over a whole upon 2, which gives negative b over 2a. So this is our second property of the graph. So when the graph is in the standard form, ax square plus bx plus c, in that particular case, the axis of symmetry is given by x is equal to negative b over 2a. See, on the axis of symmetry, for any value of y, the value of x always remains negative b by 2a. It is a vertical line. So this becomes our axis of symmetry. So we have seen the x-intercepts. These two are the x-intercepts, and this is the axis of symmetry. Now, let us see what will be the y-intercept for this curve. What do we mean by y-intercept? Y-intercept is the point where the x coordinate becomes 0. Okay, so let's sketch the curve quickly here again. Our curve was like this. Okay, we are interested in finding this point, and for this point we know that x will be equal to 0. X will be equal to 0 for this point. Okay, so our equation is y is equal to ax square plus bx plus c. We put x as 0 to find the y-intercept. So y-intercept is basically equal to a into 0 plus b into 0 plus c, and we get the y-intercept as c. So c in the standard form, ax square plus bx plus c. C is the y-intercept. I hope this much is clear to everyone. So this point here will become 0, c. Okay, so let's go back to our graph. We have seen the axis of symmetry here, which is negative b by 2a. Remember, a is the coefficient of x square, b is the coefficient of x, and c is the constant term. So x becomes negative b by 2a, and the two zeros are minus b minus root delta by 2a and minus b plus root delta by 2a. These are the x-intercept, and the y-intercept, as we have just now figured out, is this is the y-intercept, and this will be c. So the coordinate of this point will be 0, c. Okay, so this is our y-intercept, which is equal to 6. This is our axis of symmetry, and these two are the x-intercept. So these are some of the properties of the graph of a quadratic function when it is in the standard form. In the upcoming videos, we will be covering the properties of the graph when the quadratic function is in the intercept form and when the quadratic function is in the vertex form. So if you have any doubts related to this video, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel, Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.